Okay, today is the second day of notes on simple and compound probability. So you should have already done all of this. And we're moving on to the backside. Go ahead and press pause on the video and copy down whatever you need to copy down. I'm going to assume you already did that. And we're just going to move on to the notes. Here, we're going to go ahead and start setting up probability trees. Probability trees are organized pictures indicating the possible outcomes of multiple independent events with branches, okay? So for example, if you were to flip two coins, like what are some of the options that could happen, right? Now you're gonna get students that say, well, there's two different things that can happen. Like they can either match or they might not match. Other students will be like, no, there's three things that can happen. You can get tails and tails, or you can get one of each, and you can get heads and heads. Actually, both of those are technically not correct. So what we're going to do is we're going to set up probability trees. So that way you can kind of picture what's going on. Now, when you're flipping two coins, there are two events that are occurring at the same time. You're flipping a coin on the left side, let's say a quarter, and you're flipping a coin on the right side, let's say a dime, right? So because there's two different events, I'm going to start off the first event with a dot. And right here, I'm just going to put like C1, so that way you know it's coin number one. You can picture that as a quarter. Okay. Now, when you flip that quarter, there are two different things that can happen. You can either land on a heads, or you can land on a tails. So this is what the options are for coin number one. It can land on a heads, or it can land on a tails. Actually, let me go ahead and move this over here, right? Just so you can kind of know. So on that first coin, you can land on a heads or you can land on a tails. Now, that doesn't mean you're done, right? We still have to consider coin number two. So let's pretend on coin number one, you landed on a heads. You're right here. At the same time, coin number two has two different possibilities as well, right? We can branch out two different ways. So for coin number two, I'm going to put a little thought bubble right here and say, if I landed on a heads with coin number one, then for coin number two, I also have two different choices. I can either get a heads on coin number two, or I can get a tails on coin number two. So this path up here says you got a heads on coin one, and then you got a heads on coin two. It didn't have to be like that. Like you could have landed heads on coin one and then got a tails on coin number two, right? That's assuming that coins number one was a head, but it didn't have to be a head. It could have gone a tails. And if it would have gone tails, then you still have to worry about coin number two. So again, we're going to branch this out and say on coin number two, if you would have gotten heads first, then on the second coin, again, you have two different options. It can either be a heads or it could be a tails. So guys, there's four different combinations that are possible. You can get a heads and a heads, you can get a heads and a tails, you can get a tails and a heads, or you can get a tails and a tails. Now, some students get confused and say, wait, Mr. Lechuga, aren't these two the same thing? And I will say, kind of, like, it's actually a different combination. I know you're seeing a heads and a tails and a tails and a heads and saying, like, does it really matter? It is a different combination because what we're saying is here, the quarter was a heads and the dime was a tails. And on this one, we say that the quarter was a tails and the dime was a heads. All right. So if you think of these like pink ones, kind of like the quarter, and these ones being the dime, then again, this one says that the quarter was a heads and the dimes was a tails. This one's saying that the quarter was a tails and the dime was a head. Um, so yeah, you just understand it's a different combination. The outcome is kind of still the same, like you still got one of each, but the combination is different. So there's two different ways of getting one of each. Okay. All right. Let's talk about rock paper scissors. In rock paper scissors, again, there's two different events going on, right? You have player one selecting something and then player two selecting something else. So here, there's going to be two different events. Event number one is going to be player one making a decision. Now, assuming that these decisions are happening at the same time, that's going to be independent of what player two does, right? So assuming that you're only focused on player one, what are the options that he has? Well, player one has three different options. He can either go rock, or he could go paper, or he could go scissors. Those are the three options for player number one. Now, assuming that player number two is not cheating, then they are also having three different options, right? Like assuming that they're going at the exact same time and they're not waiting for the first person to make a decision. So let's pretend that player one goes with rock. Now we're going to figure out, all right, well, what are the options for player two? If player one goes rock, player two also has three different options. He can go rock, or he can go paper, or he can go scissors. So when I look at this combination right here, right, this last dot over here, I would say that player one went rock and player two also went rock. So it was rock with rock. If I look at this option, then it looks like player one went rock, but player two went paper. And if I look at this option, then it looks like player one went rock and player two went scissors. Okay. Now, those are all the options, assuming that player one went rock, but player one did not have to go rock. Player one could have gone paper. And if player one went paper, then again, then player two has three different options. They can go rock, they can go paper, they can go scissors. And then similarly, that's just if player one went paper. If player one went scissors, then again, player two has three different options. Could have gone rock, could have gone paper, could have gone scissors. So how many different combinations are there? Well, at the very end, we're just going to count up how many different last minute things there are. There's 1, 2, 3, 4, 5, 6, 7, 8, 9 different possible things that could happen if we're playing a fair game of rock, paper, scissors. Let's just go over all 9 of those options. The first option was rock, rock, which means it's a tie. The second option is, I guess I better write this a little bit smaller, rock, paper. And in that case, if it's rock and paper, player two wins. If it's rock and scissors, then player one wins. If it's paper and rock, then man, I haven't player one wins. I'm like struggling with this, guys. Player paper and paper, this is a tie. And then paper and scissors, this one player two wins. And then lastly, we have scissors and rock. Scissors and rock, we have player two that wins. Scissors and paper, we have player one that wins. And then scissors and scissors, we have a tie. So if I were to ask you, is this a fair game? Well, I want you to notice that player one wins here, here, and here. Player two wins here, here, and here. So how many different ways can player one win? Well, there's 3 ways. 3 ways out of 9, which is a 1 in 3 chance of winning. And for player two, it's also 3 out of 9, which is also 1 in 3 chance of winning. So there's a big misconception as to what makes a fair game. A lot of students say it's a fair game if you have a 50-50 shot of winning. Well, guys, this is not 50-50, right? 1 in 3 means you have a 33% chance of winning. But you know what? So does player two. Player two also has a 33% chance of winning. Is this a fair game? Absolutely. But it's not because it's 50-50. It's because each player has an equal percentage chance, right? They have the equal number of ways of winning. Okay, there's equal percentages of winning. What happened to the other 33%? Well, it's the tie, right? And again, the tie means like you both have an equal chance of winning. All right, so that is what a probability tree looks like. Okay, so probability trees is when you select the different events and start branching out from there. There's also things called probability tables. Probability tables is kind of the same thing, but we do this through a table, and you put the event of the first thing on the top and the event of the second thing on the bottom. I'm sorry, on the left-hand side. So let's say we roll a pair of dice and find the sum. Now, for a pair of dice, we could do this again, right? We can kind of calculate it this way by making a tree. But with tables, because we're adding up, with dice, because we're adding up the sum, like if I roll a 2 and a 3 and I add them up and that gets a total of 5, it's actually better if I use a table. So let's see. We're going to roll a pair of dice. Now, if I roll a 2 and a 3, That is a little bit different than rolling a 3 and a 2. That is the same. I mean, I know you get the same answer. You get 5 and you get 5, right? But the event is different. So in order for you to kind of see this, I'm going to say over here, I have a blue die. And over here, I have a red die. Now, what could happen on that blue die? Can you do me a favor and make this line like super duper thick when you make this line right here? You're going to make another super duper thick line. Guys, this is going to look like the times tables charts. Okay, so that's where we're kind of aiming for. On that blue die, what could I get? Well, on the blue die, I can get a 1, or I can get a 2, or I can get a 3, or a 4, or a 5, or a 6. I'm going to go ahead and kind of complete this table like this. So on the top, it's just like the options of what could happen. On the top, I can get a 1, a 2, a 3, a 4, a 5, or a 6. All right. So that's on the blue die. Well, what could I get on the red die? On the red die, if I roll a different die, right? By the way, a die looks like this. If you're not familiar with them, it's like a little cube that has 6 different sides on it, numbered 1 through 6, which means on the red die, I can also get a 1, 2, 3, 4, 5, or 6. Let's say, oh, let me go ahead and finish up the table before I move on. And guys, I know I'm going to go a little bit fast on this video. If you need a pause, please feel free to do so. Let's say I land right here. How did I land here? What happened? Well, it looks like on the blue die, I rolled a 3, and on the red die, I rolled a 2. If I rolled a 3 and a 2, that means I must have rolled a sum of 5. What happens if I landed here? Well, that means on the blue die, I rolled a 5, and on the red die, I rolled a 3. If I rolled a 5 and a 3, that means I must have rolled an 8 total. We'll do one more. Let's say I landed here. If I landed here, that means on the blue die, I rolled a 6, and on the red die, I also landed a 6. Sorry, guys, it's early. And that means I rolled a total of 12. Now, I know I'm adding them up like this, right? But go ahead and fill out the rest of the table. I'm going to press pause in the video, and I'm going to fill this out so that way the video doesn't become as long. Oh, actually, I guess I can't do that on this one, so we're going to go really fast. If you added them up, you should start noticing a pattern that looks something like this. Again, you really should be verifying that these numbers are true. Press pause on the video if you have to, because I did go kind of fast. I'm just trying to make the video not so long. So that's a lot of different things that could happen. Now remember, this is a combination right here, right? This is me rolling a 1 and a 1. So that's one thing that could happen. This is me rolling a 2 and a 1. This is me rolling a 1 and a 2. How many different combinations are there? Well, let's count them up. Let's see. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And if I keep counting by sixes, that's 18, 24, 30. There are 36 different combinations here. Now, out of those 36 combinations, how many of them gave me a sum of 1? Well, out of these 36 boxes right here, I don't see a single one here. So the chances that I roll a 1 on a pair of dice is 0 out of 36. That's why when we were playing the 10 O's game, if you put your number on 1, you had no shot. All right, let's see. What was the probability of getting a 2? Well, as far as the 2 is concerned, it looks like this is the only spot that gave me a 2. So how many 2s are there? There's only one way of getting a 2. You have to roll a 1 and a 1. Like, that's the only way you can roll a 2. You have to get a 1 and a 1. And out of the 36 combinations, there's only one way. So you got a 1 in 36 chance of doing so. Okay. What's the probability of getting a 3? Well, let's see. 3s, I see that there's this 3 here. and there's this 3 here. Notice I'm not counting these 3s because you have to add them up, right? You have to add up the 2 dice together. So this is me getting a 2 and a 1, and this is me getting a 1 and a 2. Remember, that's a different combination. So there's 2 different ways of getting a 3. You got a 2 out of 36 chance of getting that 3. Let me go ahead and highlight this in green just so we can kind of see where these numbers are coming from. Okay, and I think that's it, right? 2 out of 36 chance. How many different ways can you get a 4? Well, it looks like there are this way, and this way. You can roll a 3 and a 1. You can also roll a 1 and a 3. And finally, you can also roll a 2 and a 2. So there's 3 different ways of getting a 4 out of the 36 combinations that we came up with. If you were to go ahead and continue this, you would find out that the 5s are 4 out of 36. The 6s are 5 out of 36. There are 6 different ways of getting a 7. And then here's where you have to be careful. For the 8s, I see 1, 2, 3, 4, 5 different ways of getting an 8, not 7. Okay, so here there are 5 different ways of getting an 8. So that's 5 out of 36 different combinations. And then it becomes 4 out of 36, 3 out of 36. Man, I've done this so many years, guys, and every single time I forget to put that 11 there. There are 2 ways of getting 11 and 1 way of getting 36. And I forgot to highlight this in yellow, and go ahead and do that as well. Hey, take a look at these numbers. If you were to consider like, hey, what's the easiest number to get? Well, which one gives you the most opportunities? It would be this 7. 7 is the easiest number to get. Why is 7 easiest a number to get? Well, because there's 6 different ways of getting a 7. You can roll a 6 and a 1. You can roll a 5 and a 2. You can roll a 4 and a 3. You can roll a 3 and a 4. You can roll a 2 and a 5. You can roll a 1 and a 6. There are 6 different ways of getting that 7, and there's only one way of getting a 12. So when students, or when I hear people say like, oh, 7 is my lucky number, I think a lot of it harpers back to this, where on dice, like 7 is the easiest number to get. It's not that it's lucky, it's just mathematically, that's the one that gives you the most opportunities to do it. I've never, ever heard anyone say like 2 is my lucky number or 12 is my lucky number, because they just don't pop up as much. So now if you were to pick a number, like what do you think is going to show up the most when you roll a die? Well, more likely than not, the 7s are probably going to show up the most. Now, let's say that you couldn't pick 7. Then what would be the next luckiest number? The next luckiest number, and again, it's not luck, it's more duh, like the 6 is pretty easy to get. But you know what? That 6 is tied with the 8. The 6s and the 8s, they are going to pop up pretty often too, because there's 5 different ways of rolling an 8 and 5 different ways of rolling a 6. So hopefully this is making more sense on why we saw what we saw when we were doing those die activities. All right, last one, guys. We're going to do a probability table where we are going to spin the spinner and we're going to roll a die. All right, so I'm going to do a table just like last time. I'm going to go a little bit faster this time. Let's see. I'm going to roll a die. And I'm going to spin the spinner. Just like last time, we're going to go ahead and make this table kind of big. All right, this first part is pretty easy. What could happen when you roll a die? Well, there's a few things that you can happen when you roll a die, and we try to make this a little bit easier on us. You can roll a 1, you can roll a 2, a 3, a 4, a 5, or a 6. This part is not the hard part. Now, the next part is what gets students kind of a little bit. When I said, hey, what could happen when I spin a spinner? Now, the spinner that I have on the side, look at the spinner. And of course, you can't look at it because I have it zoomed out. But look at what happened. Look at the spinner on the side. I'm going to get 2 different answers. I'm going to say, oh, there's 3 different things that can happen. And I'm going to get other people that said there's 4 different things that can happen. So now the question becomes, do you think it matters that there are 2 green spots here? Does that change anything? Or would it be the exact same thing as having something that looks like this and it just said pink, green, yellow? Obviously, this spinner is different. So I got to account for this change here. It does matter that there's two green spots because I might land on this green spot or I might land on this green spot, and that gives me an extra chance. So what I want you to do is I want you to think of like this. I can either land on the first green spot or I can land on the second green spot because it does matter. It's a different outcome. I'm sorry, it's a different option, but the outcome is still going to be the same, right? Like it's a green space, but you have to count it twice because there's two of them. So here's what we're going to do. We're going to say, well, you can either land on the pink spot, or you can land on the green spot. That would be green number one, or you can land on the yellow spot, or you can land on the green spot again, but that's green number two. Now on this one, we really can't say like, oh, add the die with the spinner, right? Like that doesn't really make sense. So when we start making these, here's how we're gonna do it. On this one, I'm gonna say, all right, on this one, I landed on one and I got a pink. So I'm gonna write 1P. On this space, I rolled a 2 and I landed on pink. So I'm gonna write 2P. On this one, I rolled a 3 and I landed on pink. So I'm going to write 3P, 4P, 5P, 6P. What about for this one? Well, on this one, I rolled a 1. And then I landed on the first green spot right here. So I'm going to call this 1, G1. This one's going to be 2, G2. 3, oh, that messed up. I messed up. That's not 3G2. Sorry. That is 2G1. Because again, I rolled a 2, but I still landed on that first green space. Here, I rolled a 3, and I still landed on that first green space. I rolled a 4, and I landed on that first green space. So this is 5G1 and 6G1. On this one, it looks like I rolled a 1 on my die, and then I landed on the yellow spot. So I'm going to call this 1Y. 2Y, 3Y, 4Y. That's what happens when I try to go too fast. 5Y, 6Y. And then last one, this one is I rolled a 1, but this time I landed on the second green spot. So not only did I roll on this one, but when I spun my spinner, I landed on this piece of the spinner. So I'm going to call this 1G2. This is going to be 2G2, 3G2, 4G2, 5G2, 6G2. All right, just like last time, we're going to ask ourselves how many different combinations are there. So I'm looking. Let's see, combinations. It looks like there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. There are 24 different spaces. And that makes sense, guys, because look, there's 6 different options here times 4 different options here. 6 times 4, that's how I'm getting that 24. Same thing over here. There were 6 different options for the die. 6 different options for the die. 6 times 6, that's 36. Okay. We'll get back to that later. Hey, what's the probability that when I played my game, not only did I get a pink, but I also got a 5? So let's look at my table. Which ones are pink and a 5? Well, here are my pinks. Here are my pinks. And the only one that's a pink and a 5 is this one right here. So there's only one way of doing that out of, we said, a total of 24. What's the probability that I landed on pink? Again, I don't really care about the number. I just want to make sure that I landed on pink. So let's see. Did I land on pink here? Yep. Pink. Yep. Pink. Yep. Pink. Yep. Pink. Yep. Pink. Yep. And that's it, right? There are no other spaces that have pink. So this is 6 out of 24. And remember that on formative, you are going to have to simplify those answers. So if you have 6 out of 24, that's the same thing as 1 out of 6 chance. All right, let's see. What's the probability that I landed on a green and on a 3 at the same time? So it's got to be a green and a 3. Let's see. These are all pink, so it's not that. These are greens, but that's a green and a 1. That's a green and a... Here's a green and a 3. That's 1, and not these. These are all yellow, so no. This is a green and a 1. This is a green and a... Here's a green and a 3 as well. So I can either roll a 3 with G1, or I can roll a 3 with G2. There's 2 different ways of me doing this. So that's 2 out of 24 ways, which means you got a 1 in 12 chance of getting a green and a 3. What's the probability that I land on a yellow and it's an odd number? Well, my yellows are here, but I want it to be yellow and odd. So this is yellow and odd. That one's not. This is yellow and odd. That one's not. This one's yellow and odd. That one's not. It looks like it's 1, 2, 3 out of 24. This does simplify to 1 out of 8. All right, guys, almost done. We got 3 more questions. What's the probability that it's pink and it's a number less than 5? Pink and a number less than 5. Well, here are all my pinks, but I want it to be pink and less than 5. This is 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 pink, but equal to 5. That is not less than 5, and this is not less than 5. And I'm not even worried about the other ones because the other ones are not pink. So it looks like it's only 1, 2, 3, 4 out of 24, which makes it a 1 in 6 chance. All right, what's the probability that you get a green? Well, I just need it to be green. So none of these are green. All of these are green. I don't care what I got on the die. All of these are green. None of these are green. All of these are green. So it looks like it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 out of 24 chance, which makes it a 1 in 2 chance. Half the time you're going to land on a green, guys. Half the time. And then last one, what's the probability that you get a 2? Again, I don't care about the color. I just care that you get a 2. So then here's a 2, here's a 2, here's a 2, here's a 2. It looks like it's 4 out of 24, which makes it a 1 in 6 chance. All right, guys, sorry for the long notes, but that is what it is. If you have any questions, as always, please feel free to ask.